Dear friends, this is my tutorial 41. In this tutorial I am going to teach you how to calculate Gibbs free energies of reaction using Gaussian computed energies. So this is the Gibbs free energy profile. This is the catalytic mechanism of nitrogen reduction with this HIPT ligand. So this is my calculation folder. So I will show you that paper. This is the paper published in Inorganic Chemistry. So in this paper they have did that nitrogen reduction reaction with this HIPT vanadium catalyst. In this paper only they have calculated the free energy profile. I will show you that one. So this is the free energy profile of this catalytic cycle. So here you can see they will calculate from 1 to 2, 2 to 3, 3 to 4, 4 to 5, likewise. Finally the final step is 14 to 1, that is removal of NH3. So this is the catalytic cycle of this energy profile. Here they will use 6 electrons and 6 protons to produce 2 equivalent of ammonia from this N2 molecule. So we will see how they calculated the free energies of this energy profile. So next I will show you that they also given that energies of the each system in supporting material. I will show that one, you will understand easily. So this is the supporting material of that corresponding paper. If you go down you will find the table S5. This is they listed that energies of all the intermediate and also the small molecules and the proton source and also electron source. So here you can see this is the molecule, this is the solvent corrected energy, this is the 0 point energy. So this is the thermal correction energy, this is the thermal correction to Gibbs free energy, this is the final corrected energy. So we are going to use these energies to compute that Gibbs free energy, and also we will see how they plotted that Gibbs free energy profile using these energies. So here this is the decamethyl chromosine. This is CP star CR means decamethyl chromosine. This is the electron sources for this reaction. So the lutetium H plus is the proton sources of this reaction. So after releasing this proton it will form the lutetium. This is 2,5 dimethyl pyridine. This is CP star means decamethyl chromosine. So this is the CP star CR means the neutral system. After releasing one electron from this decamethyl chromosine it will form the positive charge. That's why they mentioned the CR plus. So you have to optimize two system. This is that 0 charge, this is +1 charge. Likewise here also you have to optimize this 0. So this is +1. So just you can optimize, you can keep, and you will get these energies. The corresponding you will get like this energies. We can use these two energies to calculate the Gibbs free energy of these reactions. So now we will calculate the Gibbs free energy. So this is my calculated file, Gibbs free energy file. So this is the Gibbs energy calculation using Gaussian energies. The first step we are doing that 1 to 2. This is the first step is N2 binding step. So already I showed that energy profile. So first step is 1 to 2 is N2 binding step. So we are going to calculate that first N2 binding step. So this is actually a reaction HIPT. This is the vanadium catalyst. So this is the N2 free molecule. We are going to absorb this N2 molecule with HIPT vanadium catalyst. So after a binding you will get V and N2. Absorb the N2. So how to calculate the delta G? Earlier video also I calculated the delta G using that Gaussian manual. You can also see if you want to know slight detail. So here I will tell you how to calculate this Gibbs free energies delta G. So HIPT N2, this is actually product. So you have to put your product is left side. So you have to put your reactant everything in the right sides. So you have to subtract these two energies and you will get that corresponding Gibbs free energy. So I added that energies. This is the HIPT N2 energy, this HIPT vanadium energy, this is a N2 energy. I will show this energy into that supporting material file. So actually I have mentioned here 1 3 2 3. 3 means that spin multiplicity, 3 is the stable, triplet state is the stable for this two things. That's why they mentioned the 1 3 2 3. So if you see here also, you will see the singlet triplet is that. So the triplet means the 1 3. Okay, the second one is 2 3. 2 3 means this is the 2 means this is the singlet, 2 this the triplet state. We have to take this triplet energies. So I took that triplet energy 527 142 39. So this is the triplet state energy. Here also I took the triplet state energy, this catalyst. Here this the N2 free N2 energy. You can go down, you can find that N2 energy. This is the N2 molecule. So this is the 109.35672. So that's all. Just you have add these two energy, you will keep here. Similarly, you take directly this energy here, because only one intermediate only is that this side. So just you can subtract these two energy using calculator. I will tell you how to do that one. Just to copy this, go to calculator, so you will get 0.01128. So I copy pasted here, you can see 0.118. So then you have to multiply. This is actually R3 energy, so we need to convert into kilocalories per mole. For that what we have to do, this is the conversion factor for R3 to kilocalories. Just we have to multiply with 627.509. So just we can multiply 627.509. You will get 7.707. That means, so if you round up this value, you will get 7.10. So that's why I mentioned minus 7.1 kilocalories per mole. So this is the first step. Now I will show you the second step calculation. This is also very important. Just listen. So here we can see step 1 to 3 we are going to calculate. So here you can, what are the intermediate we have to put. This is the initial structure, that means the catalyst. Then you have to put N2. Then we have to put lutetium. Lutetium means with proton. So this is, I will show you the structure. Otherwise you can just put lutetium, you will find this kind of structure. What is that one? So this is the actually proton source. So we are going to add one proton to the this N2. So finally what you get, reaction that N2 will absorb here, then proton will go to the one of the nitrogen. It will form the VNNH plus free lutetium without proton. This is the second step. So I also calculate the delta G for this step. Here you can see HIPT NNH. This is the product actually. So this is the this also product. So what are the things coming that in the reaction right side? So we have to put in the calculation left side. So these two things we have mentioned here. Then we have to put the initial structure HIPT V and N2 and lutetium H plus proton source. So you have to take these three energies. So I mentioned here, you can see this is the catalyst energy, this is the N2 energy, this is the lutetium energy. So I will show you in that folder lutetium energy. If you go down here, you can see this is the LUT H plus. So 326.45256. So 4525259. So I mentioned here 259. Okay, so then you see this one HIPT VNNH. This is that energy. This is the lutetium energy. This is the lutetium ion. This is the lutetium 326.06847. So this is that energy. This I mentioned here. So here you have to see this also this is the third step in third intermediate. This is the this is also triplet state. If you go to third one, you can see this is the third one, triplet. We did not took the singlet, but because this is the more stable one, so you can also find out the energy. The singlet one is 637.60, this is 637.64. This is the more stable than this one, that's why they are using this triplet state. So here you can see 636.91.985, just I mentioned here that energy. So just you can add this 2 energy, put here, then you have to take this energy, this 3 energy, put here, just you can subtract this 2 energy. So you will get the corresponding corresponding energy. Then we can convert into kilocalories per mole. For that we are getting 0. So this is the energy. I already copy pasted, just I will show you that. So 03662. So if you want to convert into the kilocalories per mole, just multiply with 627.509. That's all. We will get 22.97. that means 22.97 means this around 23. So in the page we can also check with that profile, these 2 steps. So first step, what you got, 7.1. so if you see here, they also got 7.1 only. You can see here minus 7.1, the first step, N2 binding step. Second step is 23.0. so we also got 22.97. if you round up this one, we will get 23.0. similarly we have also got 23.0. next we will see the reduction step, that is also very important. So this is the step 1, this is the 2, this is the 3 step, third step, reduction step. So here you can see we are going to use that decamethylchromosine energy, because that is the reducing source, that means electron sources of this catalytic reactions. So this is that simple reaction. So we are going to initial this one, then we have to N2, then lutetium and decamethylchromosine. This is neutral. So in the right side you can see product, that vanadium NNH. So actually, so we are going to reduce that plus to 0. So actually in this step what will happen, you will get that plus. After adding one proton to the N2, it will, the total charge will change into the plus. So now we are going to reduce this plus into 0. That's why we are, this is that step. So you can see this is the reduced one, the product NNH, then the lutetium. Similarly what you mentioned earlier, just you have to add here also. Here also you have to put that decamethylchromosine. After reducing that decamethylchromosine, you will get this loss of electron, oxidized species of decamethylchromosine. So this is the things we have to put all the energies, then we will get our the Gibbs free energy. So this, then we will calculate the Gibbs free energy. This is the delta G equal to HIPT NNH. This is the product, this is the reduced product, then lutetium. So this is the right left side, the product we have to mention. This is the decamethylchromosine after oxidized species. That means these 3 things are product side. So this 4 things are we have to put in the reactant side. So HIPT catalyst, N2, lutetium and decamethylchromosine. So likewise you can add all the energies in the down. Just you can add this total energy, put it here, and also you can also add this 3 energies, put it here. Just you can subtract with your calculator. So you will get 0.0216. So this is the one. Then multiply with that conversion factor 627.509. So you will get 13.40. You will get, this is the formation of this product. That means HIPT So VNNH reduced species. So here I took that. Here you can see one is the triplet state only, the third one is the doublet state we took the energy. So I will show you that in that supporting material paper. So if you see the catalytic cycle, you can see this is the fourth one, actually NNH. So actually you have to change, this is the fourth one, sorry, fourth one is doublet. So this is the NNH, we can see here. So the fourth one is a doublet only, they mentioned. The doublet energy is, this is the one, 637.03344. So that energy I have mentioned. So likewise you have to choose the correct spin multiplicity to get that lowest energy structures. So likewise you have to do. Then I will also calculate the final step. So you should also know, that is the formation of lost NH3 molecule. So this is that one. So this is you can see this is the vanadium that catalyst N2 molecule. So the final step means we have to use 6 equivalent of proton, 6 equivalent of electron. So that's why I mentioned the 6 LUTH plus and 6 decamethylchromosine. So we are going to use these three things to produce HIPT VNH3, and one first it will form the first NH3, the NN will cleave and we will give one product. You can see that in that catalytic cycle. So in this pathway what will happen, so NN cleavage will happen, it will produce first equivalent of ammonia. You can see here that from 8 you will get the first equivalent of ammonia. So this is the first we have got, that's why I mentioned here NH3 here NH3, and 6 lutein and 6 that oxidized species of decamethylchromosine. So this is that reaction. So here you have to put that left side, you have to put your products. So HIPT vanadium NH3 plus this that protonated one, we have to, that's why we are mentioning the plus. Then that formed NH3 molecule, then 6 lutetium, and this the 6 oxidized species of the decamethylchromosine. Likewise in the right side you have to put your reactant. This is that catalyst N2, 6 lutetium H plus 6 the neutral decamethylchromosine. So likewise you can add all the energies in the down. Just you can add this 1 2 3 4 energies, put it here, and here you can add 1 2 3 4 energies, put it here. Just you can subtract these two energies, you will get that 31004. I already mentioned. Then you have to convert into electron volt RT to kilocalories per mole. For that 627.509 multiply with this value, you will get your 194.6. So this is the last step I will show you in that catalytic cycle. Actually I did not calculated this step because I calculated this step. So I also tried to calculate, but I could not get that exact this value. Maybe they did something wrong in that, I think so. That's why I could not get that exact value. So just I calculated this one, I got exactly 194.6. So I used here 14 1 spin multiplicity, I think. So that's why I mentioned 14 1. So we have to use 14 the doublet state. So I did not use. So I used the 14 singlet state. We have to use that triplet state. See here they mentioned, I think the 14 is a triplet state. So I tried to calculate, but I could not get this energy. So I don't know, they maybe did wrong or not. So just you have to you can also check if you want that one. So this is the things. So I will share this file to you. Just you can calculate using this method. This is the correct method to calculate Gibbs energy calculation from the Gaussian energies. So I will share all the document to you. Just you can follow this one. So thank you for watching my video. If you like my content, please like, subscribe, comment and share, and also please click the bell icon for future video update. Thank you. So if you like really my contents, please subscribe and share to your friends and also all other related friends. Thank you so much. Thank you for watching. Please subscribe. Thank you.